Space may look silent and empty, but it's full of stories. One of the greatest is the story of a star. From its quiet birth in a cloud of gas to its spectacular death in a supernova, the life of a star is one of the most incredible journeys in the universe. Let's follow that story, step by step. Stars begin their lives in enormous, cold clouds of gas and dust drifting through galaxies. These regions are sometimes called stellar nurseries. They're made mostly of hydrogen, the simplest and most abundant element in the universe. Inside one of these clouds, something starts to happen. Gravity causes a small region to collapse in on itself. Sometimes this is triggered by the shockwave of a nearby supernova, or the passage of a spiral arm in a galaxy, which compresses the gas. As the cloud collapses, it starts to spin faster and flatten into a disk. At the center, the material piles up, getting hotter and denser. This growing, heating ball of gas is called a protostar. Over time, the core becomes so hot, tens of millions of degrees, that hydrogen atoms begin to fuse together, forming helium. When fusion begins, a star is officially born. The energy released by fusion pushes outward, while gravity pulls inward. The two forces balance perfectly, creating a stable star that can shine for millions or billions of years. This stable phase is called the main sequence, and it's where stars spend most of their lives. Our Sun is currently in this phase. It's been shining steadily for about 4.5 billion years. Every second, it fuses about 600 million tons of hydrogen into helium, releasing enormous amounts of energy in the process. But not all stars are the same. Small stars, known as red dwarfs, are cool, dim, and live incredibly long lives. Some will burn for trillions of years, longer than the universe has even existed so far. Medium stars, like our Sun, shine for billions of years before changing. Massive stars live fast and die young. They burn their fuel so rapidly that they might only live for a few million years. Astronomers group stars by mass, temperature, and brightness. On a diagram called the Hertzsprung-Russell diagram, stars trace out a clear pattern. The main sequence is a long diagonal band where stars spend most of their lives. Above and below it, we can see the giants and dwarfs in different stages of stellar evolution. This simple diagram tells us an enormous amount about a star's past and future. As a star ages, the hydrogen in its core runs out. When that happens, the delicate balance is disrupted. With no more hydrogen to fuse, gravity starts to win. The core contracts, heating up, while the outer layers expand. The star becomes a red giant, or, if it's a very massive star, a red supergiant. This is what will happen to our Sun in about 5 billion years. It will expand so much that it might swallow Mercury and Venus, and possibly Earth. Meanwhile, in the core, new fusion reactions begin. Helium starts fusing into carbon and oxygen. In massive stars, the fusion continues in stages: carbon to neon, neon to oxygen, oxygen to silicon, building up heavier elements layer by layer, like the layers of an onion. Eventually, the core fills with iron. And here's the problem: fusing iron doesn't release energy. Instead, it uses it up. When a star reaches this stage, it's living on borrowed time. For smaller stars like our Sun, the end is relatively peaceful. After the helium is gone, the outer layers drift away into space, forming a glowing shell called a planetary nebula. Despite the name, it has nothing to do with planets. Early astronomers just thought they looked like planetary disks. The core that remains becomes a white dwarf, a dense, hot object about the size of Earth, made mostly of carbon and oxygen. A single teaspoon of white dwarf material would weigh several tons. Over trillions of years, a white dwarf slowly cools down and fades away, eventually becoming a black dwarf. The universe isn't old enough for any black dwarfs to exist yet, but they will be the final stage for most stars. But for massive stars, the end is far more dramatic. When the iron core can no longer resist gravity, it collapses in an instant. Protons and electrons are crushed together to form neutrons, creating a neutron star. The sudden collapse sends a shockwave through the star's outer layers. The entire star explodes in a titanic supernova. In just a few seconds, it can outshine an entire galaxy. In that moment, the extreme conditions forge elements heavier than iron, gold, platinum, uranium. These are scattered into space by the explosion. Every atom of iron in your blood, every bit of gold in a ring, every trace of heavy elements on Earth was created inside stars and spread through space by supernovas. In a very real sense, we are made of stardust. The story doesn't end with the explosion. The material thrown out by dying stars mixes with the surrounding gas and dust, enriching it with heavy elements. Over time, this enriched material forms new stars, new planets, and eventually, life. This cycle has been going on for billions of years, generation after generation of stars. Even the remnants of massive stars continue to shape the cosmos. If the collapsing core is massive enough, not even neutrons can stop gravity. The core collapses further, forming a black hole, a region of space where gravity is so intense that nothing can escape, not even light. Black holes aren't just cosmic vacuum cleaners. They can spin, emit powerful jets, and even help regulate how galaxies evolve. Supermassive black holes at the centers of galaxies seem to influence star formation on galactic scales. Neutron stars, on the other hand, are some of the strangest objects in the universe. A neutron star packs more mass than the Sun into a sphere only about 20 kilometers wide. They can spin hundreds of times per second, emitting beams of radiation like cosmic lighthouses. These are called pulsars, and we can detect their regular pulses from Earth with radio telescopes. Some neutron stars merge in violent collisions, sending ripples through space-time called gravitational waves, signals that have been detected on Earth in recent years. These mergers create even more heavy elements and may be one of the main sources of gold in the universe. Stars are more than just distant points of light. They are the engines of the universe, powering galaxies, creating elements, and making life possible. Every star in the night sky has a story. Some are being born right now, hidden inside cold clouds. Some are shining steadily in their prime. Others are aging, swelling into giants, or have already exploded, their light just reaching us after thousands or millions of years of travel. The next time you look up at the stars, remember, the light you see is part of a cosmic story billions of years in the making. It's the story of creation, transformation, and rebirth. We are living in a universe written in the language of stars.